In the first episode, we explained why Delmic Cryo started our journey to revolutionize cryo-ET technology. Starting from this episode, we present to you the R&D stories of our engineers who are working very hard to create the next generation fully automated cryo-EM system. Now we're going to meet the first engineer, Dan Bocha.
Hi, I'm Dan, and I've been with Delmic for about 3 years as an experimental physicist. More recently, I've been also working at Delft Technical University as a graduate student in joint collaboration with Delmic. Cryogenic electron tomography provides a window into life's complex machineries at near atomic resolution. For this to work, samples need to be below 200 nanometers in thickness, which can be prepared by means of focused ion beam milling. This is usually done blind, in other words, without prior knowledge of the exact location of the structure of interest. And Delmic has been working to overcome this challenge by integrating a cryogenic fluorescence microscope in a FIB-SEM. Integrating these different microscopes makes it easier to find regions of interest with biological relevance and to fabricate a lamella around it. The Delmic CECOM was the source of inspiration when we started this development, where we took the traditional CLEM approach and aligned the optical axis of the objective lens with the optical axis of the SEM. We combined the optics with a new Joule Thomson microcooler, a piezo positioning stage, and a cryogenic transfer system. During fully integrated tests, we realized how we were limited by the positioning accuracy of the sample stage and changed the design and changed the orientation of the objective lens along with the optics. We can now make full use of the integrated approach by simultaneously imaging the same region of interest with both the optical and FIB-SEM microscopes. Simultaneous coincident imaging with electrons, ions, and photons allows for quality control at every step of the way. Being able to follow the milling process with the light microscope makes that you actually see what is happening and makes it more intuitive for users. Moreover, it enables targeted milling guided by fluorescence microscopy and has the potential for sub-diffraction limit localization accuracy in 3 dimensions, which will finally allow for targeting individual proteins. We've been developing new products for the cryo market for a few years now, and I'm excited to see that after many experiments, things are coming together, and I really look forward to seeing it implemented in a cryo-ET workflow. If you want to know the other features we're working on in the ENSEL project, stay tuned for next episode.